AC motor. Basic principle. An alternating current AC motor has two major components, the stator and the rotor. The stator creates a rotating magnetic field. The rotating magnetic field acts on the rotor, causing it to spin due to the rotating magnetic torque. The rotating magnetic field from the stator is produced by the currents that are flowing through the stator windings. Basic principle. The stator windings have several poles. The poles are the number of coils in the stator and are wired to the conduit box. The poles are activated by the alternating current at different times, causing the magnetic field to move. The rotor is built like a cage and is short-circuited at both ends. The rotating magnetic field in the stator induces a current in the rotor and an opposing magnetic field. The magnetic field in the rotor reacts to the magnetic field in the stator and starts to rotate. Air intake. Using a stroboscope, check for broken air intake fan blades and clogged air intake. It is recommended to paint the fan a bright color when rebuilding or after buying new motors so it can easily be seen from a distance. Fan covers can also be painted matte black to improve the visibility of the fan. 18 degrees Fahrenheit, 10 degrees Celsius increase in temperature decreases electrical life of motor by 50%. Air intake can become clogged by particles in the air or a process leak. Damage can be caused during repair, while in storage, or during transport. Base and foundation. Inspect the base and foundation for damage and excessive corrosion. In concrete foundations, inspect for cracks, erosion, and unevenness. On a steel base, inspect for corrosions and cracks. Corrosion does not necessarily appear as rust. Properly drain process fluids, slurry, water, or seal water away from the foundation and base. Foundation and base should be clean and dry. Inspect mounting bolts and shims for tightness and corrosion. Metal bases, shims, and locking bolts should all be of same or similar metals. A damaged base and slash or foundation will cause misalignment and vibration. Two dissimilar metals will corrode when put together. Bolts and fasteners. Check that all mounting and anchor bolts are tight and free from corrosion. A corroded bolt is a loose bolt, or it will become loose soon. Replace corroded bolts. Make sure washers and bolts are made of the same material or combinations of material. If a loose mounting bolt is found, make a note and tighten it next downtime opportunity, then recheck alignment. Loose mounting bolts will gradually cause misalignment. Two dissimilar metals will corrode when put together. Tightening a bolt may pull equipment out of alignment. Electrical. Check for damaged wires. Ensure the flexible conduit is mounted correctly and not damaged. Check condition of junction box. Ensure ground strap is installed. Check the integrity of the ground strap. Exposed wiring is a safety issue. Exposed wiring can also cause short circuits and other electrical problems. Noise. Listen to the motor closely. Try to detect any abnormal noise and vibration. Noise and vibration can be caused by looseness in mounting or coupling, misalignment, worn bearings, damaged winding, and slash or broken air intake fan. Water and humidity. Check for unnecessary water or humidity around motor. Ensure that electrical connections are not exposed to water or moisture. Moisture will also cause winding damage. Even if motor is made to withstand water, there are limits for how long and how much water a motor can withstand. Water can cause a short in the motor and cause electrical leakage to ground. Temperature. Scan clean areas of motor with an infrared temperature gun. Measure temperature of the outboard bearing. Measure temperature of the inboard bearing. Measure temperature of the winding. The maximum temperature of the bearings and winding should be no more than 165 degrees Fahrenheit. Measure temperature of the outboard bearing. Measure temperature of the inboard bearing. Measure temperature of winding. The maximum temperature of the outboard bearing, inboard bearing, and winding should be no more than 165 degrees Fahrenheit, 73 degrees Celsius. 1. High temperature in the middle of the motor may indicate a damaged winding or that the motor is operating close to maximum output capacity. 2. Hot spots at the bearings may be caused by damaged bearings, misalignment, or incorrect lubrication. Check the coupling. If it is hot, the problem may be alignment. Motor circuit test. Warning: motor must be stopped. Check leakage to ground. Take volt reading and check each phase for unbalanced voltage. Electrical unbalance will cause the same problem as if the motor is mechanically unbalanced. Power quality, operation, environment, wear, and maintenance can all be causes of failure. Lubrication. If the motor has greased bearings, lubricate both bearings according to manufacturer recommendations and use an ultrasonic grease gun to hear when the grease reaches the bearing. Follow the ultrasonic gun manufacturer's recommended grease procedure. The principle is, when the grease enters the bearing, friction will decrease and lower the ultrasonic signal. Pumping too much grease will increase friction, and the ultrasonic signal will increase. If the motor has a grease fitting but no drain plug, all excess greases will go into the motor. Note: grease fittings and drain plugs are often clogged with paint. Excessive greasing will cause the bearing to run hot due to too much resistance from the grease. If the drain plug is not removed or the relief valve is not moving freely, grease will push against bearing seals and destroy them. Excess grease will eventually go into the motor winding, potentially causing winding insulation deterioration. Did you find this equipment knowledge helpful? Order your copies of all 5 condition monitoring standards online.